Hi everyone. In this topic, we are going to discuss about conic sections, circles, earthquake triangulation. Our objective is to know what is earthquake triangulation, how it relates to the circle, locate the epicenter of an earthquake using triangulation method, and the purpose of triangulation. So, what is circle? A circle is a shape or a form consisting of all points in a plane that are given distance from a given point. Next, what is earthquake triangulation? Earthquake triangulation means locating the epicenter of an earthquake, wherein seismologist utilizes the method called triangulation. So, how does it relates to the circle? The three circles in the image are the seismic stations, a recording oscillation of the Earth's surface caused by earthquakes. Circle relates to the triangulation because it helps to determine the location of the epicenter through the calculated radius. The calculated radius will be placed in any direction to produce a circle and intersecting course. With that, one intersecting point is the epicenter.
As seismologists, we are given a task to find the distance, results, and to locate the epicenter by using methods such as triangulation and the seismograph. This image right here is an American seismologist that was born in Australia and a professor of Earth and Planetary Science at the University of California, Berkeley, and Professor Bruce Abel.
So what is seismograph? Seismographs are instruments used to record the motion of the ground during an earthquake. They're installed in the ground throughout the world and operate as a part of seismographic network. As you can see at the picture, this is an example of seismometer. At the top, there is a spring that holds the weight, and under the weight is a pen that creates the motion in the rotating drum and show us the wave pattern. So what is seismogram? Seismogram is a graph output by a seismograph. It is a record of the ground motion at the measuring station as a function of time. Seismograms typically record motions in three Cartesian axes, with the z-axis perpendicular to the Earth's surface and the x and y-axis parallel to the surface. As you can see at the picture, this is an example of the waves. The first is the background noise. Next is when P arrives first, then S waves arrives, then fourth is surface waves arrives last, and fifth would be S to P time interval. So how would it will show us? So first is the earthquake happens at time 0. Then second, the first P waves arrives a little over 2 minutes later. And third, the first S waves arrives 4 minutes later. And fourth, the surface waves which travel the long way around Earth's surface arrives last. And last is the S to P interval, here slightly less than 2 minutes, tell us seismologists how far away the earthquake was. By getting the hypothetical seismogram, we can determine the time of the waves and calculate its distance.
Now for the word problem. Find the distance of the waves and locate the epicenter of an earthquake using triangulation. This is based on the 6.9 magnitude earthquake happened on December 15, 2019. Only the epicenter is given. All those calculations are made by us and the seismogram result. As you can see right here, we have the located points of the stations. The first station is the General Santos Seismic Station. Second is the Cotabato Seismic Station. And the third one is the Cagayan de Oro Seismic Station. Now let's look at the graph. Right here, these are seismic stations, the Jensen, Cotabato, and CDO. The time difference in the arrival of time of P waves and S waves is 6 seconds at Jensen, 10 seconds at Cotabato, and 16.48 seconds at Cagayan de Oro. And wherein the distance of epicenter from the station is 75 kilometers at Jensen, 125 kilometers at Cotabato, and 206 kilometers from the Cagayan de Oro. Now, for the computed distance of the map, which has the Jensen has 0.75 centimeters, Cotabato has 1.25 centimeters, and lastly, Cagayan de Oro has 2.06 centimeters.
So how do we get the lag time? This is the time and difference in the arrival time of P waves and S waves. So in this picture, this is the result of hypothetical seismogram. At Jensen, P wave is at 4 seconds and S wave is at 10 seconds. In Cotabato, P waves is at 8 seconds and S wave is at 18 seconds. In Cagayan de Oro, P waves is at 10 seconds and S wave is at 27 seconds.
So, how can we get the time and difference in the arrival time of P waves and S wave? We must follow the given formula of log time. S waves subtract to P waves and the result is the log time. For the first seismic station is the Jensen. Log time 10 seconds of S waves and subtract to 4S of P waves and the result is 6 seconds of log time. For the second station is Cotabato. 18 seconds subtract to 8 seconds and the result is 10 seconds. For Cagayan de Oro or CDO, 27 seconds subtract to 10.52 seconds and the result is 16.48 seconds. How to find the distance of epicenter from the station? We must follow the formula given by the distance. Log time divided by 8 seconds. 8 seconds there is constant, multiplied to 100 km. For the first seismic station, Jensen, 6 seconds divided by 8 seconds multiplied to 100 km and the result is 75 km. Same as Cotabato, 10 seconds divided by 8 seconds multiplied to 100 km and the result is 125 km. For CDO, 16.48 seconds divided by 8 seconds multiplied to 100 km and the result is 206 km. In converting kilometer to centimeter for map plotting, we must follow the given formula of distance. Given kilometer multiply 1 centimeter divided by 100 km. For the first station, Jensen, 75 km multiplied to 1 centimeter divided by 100 km and the result is 0.75 centimeter. Same as Cotabato, 125 km multiplied to 1 centimeter and divided by 100 km and the result is 1.25 km. For CDO or Cagayan de Oro, 206 km multiplied to 1 centimeter divided by 100 km and the result is 2.06 centimeter.
Now, how to locate the epicenter using triangulation? So we can answer this question because of the given distances in calculations that we discussed earlier. So as you can see here, we have a map and we must first plot the 3 station points, which is the Jensen, Cotabato, and the Cagayan. The first one is the Jensen, which has 75 kilometers distance from the epicenter. So we don't know which direction the earthquake was. Neither it's north, south, east, or west. So we must make this as a radius or a circle so that it is surrounded by the area of the seismic station, and in this line right here at the circle, there's a possibility that in that point of line, that is our epicenter. But we don't still know yet because we need an intersecting point. So that's why we need these two circles. The second station is the Cotabato, which has 125 kilometers in a radius. And now, as you can see right here, we have two intersecting points. But it is invalid because only the epicenter has only one point, right? The only center. So we need the third circle to make an intersecting point and make a one only intersecting point between the three circles. And that is the Cagayan de Oro third station, which has 206 kilometers in radius. Now, as you can see, there's only one intersecting point between the three circles. And that is what we call an epicenter.
So, this is the base map of the epicenter during the 6.9 magnitude earthquake. As you can see on the map, the red line is the intersecting points of the three triangulation or the three circles. So, we only discussed on how we can locate using the triangulation method. So, what is the purpose of the triangulation? The purpose of triangulation in this concept is to find the approximate location of the epicenter, just like what is shown earlier. And that is all. Thank you.
And these are the references of our research. That's all. Thank you.